Let's solve this question. It is check whether two strings are anagram of each other or not. Let's try to read the problem statement. The problem statement here says, given two strings S1 and S2 consisting of lowercase characters. Now the task is to check whether these two given strings are an anagram of each other or not. All right. Now it explains what an anagram is. Well, an anagram of a string is another string that contains the same characters. Only the order of the characters can be different. All right. For example, act and tag are an anagram of each other. The string S1 and S2 can only contain lowercase alphabets. This is a compulsion. And a note that is given here which says that you can assume that both S1 and S2 are not going to be empty. Let's see the sample test cases. It is saying that you'd have two strings S1 and S2. Now these two strings must be anagram of each other. That means we can, just by rearranging the letters of one string, we can form the other one. Okay, if that is possible, simply we have to turn true. Otherwise, in this case, if the anagram is not possible, if we cannot form up another string from the first one just by rearranging it, that means it is not an anagram and we would return the false. Okay, so you can see all these test cases. These are all the just variant of similar examples. And here you can also have such cases when you have only one letter. Well, obviously that is anagram of each other. Now coming on to the approach of it. Now the very first approach that might come to your head is going to be that let's sort both of these strings. Okay, let's say I had A, B, A, C, D, and I had A, C, B, D, A. I have these two strings. What can I do? First of all, let's try to sort both of these strings. Let's say S1 has become A, B, C, D. And once I sort the other one, S2, I can say it's A, B, C, D again. Now I have these two strings. I just need to compare these two. And I can say, okay, if the comparison is successful, all the characters are same, then we can say true. These are anagram of each other. Quite simple, right? And the comparison is going to be taking order of n because we have to compare each and every character. Sorting, on the other hand, is going to be taking n log n. So this is the dominating complexity. The total complexity of this approach can be said as order of n log n. Any extra space that we need, that would just be required for sorting. Okay. So this complexity is actually we can say a bigger one for this question. We can improve it. But we would require help of another data structure. If you want to take a guess, yes, whenever we talk about frequencies and count of the elements, we are there is a possibility we might be referring to hash maps. So what do we need to do? Well, there could be two variations of counting the frequency. First is using a hash map. Another, we can also have a frequency array. Both of the approach are quite similar. It is just that we are using different data structure to apply the same logic. What will we do? Let's suppose if we have to make up a frequency dictionary or a frequency hash map, which has frequency count of all the elements. Let me just write a random string here. Let's say we have this string. Now I have to create a frequency count of it, a frequency chart, if you want to say it like that. So in terms of hash maps or dictionaries, what will we do? We will just take up an empty dictionary. And the moment we have our A, or let's say the first character, we will check that whether that element is present in the dictionary as a key or not. If that is not present in that dictionary as a key, we will introduce a new key and we will give the corresponding value as 1. Now going on ahead, we have B, introduce a new key and write 1 towards it. Now once you go to this element A, you will check in your dictionary. Your checking operation takes order of 1. You're checking in your dictionary and you checked, okay, the key is already present. But this time, what you are going to do is you are going to increase the count by 1. You encountered C, you made one more key. You encounter another C, you added 1 to it. Then you have D, you got 1. You got E, you made one more key and had the value, you increased the value. And then you got B, you increased the value. So eventually, you have 2, 2, 2, 1, and 2. These values. All right. How much time did it take? Well, we are traversing from this place, from the beginning of the string till the end. All right. If n characters are there, then we are taking order of n time. If I am simply fetching the values and trying to check in my dictionary that, okay, if that key is present or not. For that, we take order of 1. So if now, like if in total we talk, we are just consuming order of n time. Let's talk about space a little. For space, what are we doing? We are having this hash map. Now, this hash map, or you want to say dictionary, how big it can grow, how many characters you can have. Well, the question has already limited to all the lowercase alphabets. That means only 26 characters. Okay, so our hash map is not going to be more than order of 26, or in general, you can say O1, because that is a constant. Coming on to the way of frequency arrays. The concept is completely similar. Instead of this data structure, what we would have is we would have an array of 26 elements, each initialized with 0, beginning of the traversal. It signifies that none of the element has occurred at any time. All right, and let's suppose we have the indices. According to the indices, we map of the characters. So 0 will be representing A, 1 will be representing B, C, D, and so on and so forth. Now, according to the ASCII values that we get, we try to save the count of it. Let's suppose I encountered A. So at this position, using the ASCII mapping, I would write 1 here. Okay. I encountered B. At this position, I would write 1. I encountered one more A. I would increment this value. So by the end, what I would be having is some data structure similar to this. Okay. This is how we count frequencies using hash map or a frequency array. How can this help us in this question? What do we have to do is we have to make one frequency chart for S1, another frequency chart for S2, and then we need to compare these two charts. Very simple. Once these two charts are completely identical, that means the number of keys are same and the corresponding values are same. If that is so, that means these two strings are anagram of each other. Simple, right? Let's see the code for it. Okay, so here's the code. I have created one empty dictionary here. And then what I've done is, first of all, I've created this frequency chart for S1. You can see the syntax of it. Very easy way. The one I've already told you. .get function will say that if ch is present, that means the character's key is present, then we are going to be fetching that key's value and we'll add 1 to it. If ch is not present, then the key with value 0 will be presented and 1 will be added to that. Similar concept. According to the code, we have made a slight modification there. Instead of creating a new one, what we have done is first we have created the array, the hash map. And once we have stored all the values here, what are we doing is, once we are creating up and following the same fashion in the S2, the string 2, instead of creating up a new data structure, what I'll do is, let's suppose I have 2 A's here. So every A I encounter or every character I encounter, for every corresponding value, I will do -1. Okay. So what this will lead to, like if these two strings are anagram, so eventually once this loop is executed, every value that I have would be now turned to 0 of all the corresponding keys. Because if let's say A occurred 2 times in the first one, in the next string 2, it will occur 2 times and that will be subtracted. So with these two frequencies and the same concept, eventually I will check with this loop whether all the values of the corresponding keys that I have is 0 or not. If all the values have already become 0, that means we can simply return true here. But if that condition fails anywhere, that means let's suppose you had A, B, and in the next string you only had A, B. The first hash map you make would be A corresponding to 3, B corresponding to 1. And then once you run the same loop, a similar loop of subtracting the values, in this string, what will happen? A, that means -2 will happen. And for 1B, -1 will happen. The dictionary would then become A1 and B0. What we are checking here is whether all the keys values are 0 or not. Here you can see what is happening. Well, one value is still left for this key. That means this is one extra character which we do not need. This, what happens is, you can say these are not anagram. If this condition violates, you can return false. Otherwise, if this loop is successfully executed, then you can simply return true at the end. So quite simple. The concept of counting frequencies is the same whether you use hash maps or you use frequency arrays. Now let's analyze the complexity of this code. What are we doing? Let's talk about the time complexity first. We are using this loop, which let's say is of m length, the string is of m length, so it will be order of m plus order of n, supposing this is the length of the other one. And then we are creating up the, like, we are just checking our hash map. So it is going to be order of 26, right? 26 max characters possible. So what we can say, it is order of m plus n plus 26, ignoring 26 because that's again just a constant value. We can say time complexity is order of m plus n. Now coming on to the space complexity. Well, with this little optimization here, we are just using one hash map. And what are we doing here? We are creating up a hash map which would take order of 26 every time, not more than that. So this can also be, then you can like count it as constant if you want to. Then once we are done, this code will return either true or false, and you would have a required answer. Let's try to run this code. So here we have the same code. Let's try to compile it. Okay, compiling that, we have gotten our expected output for the sample case. Let's try to submit that for testing against all the test cases. All right, so it has passed all of the test cases mentioned. So I hope now that you have got this question anagram very easily, and you can, again, as I always say, you can try run it with your own examples. You'll have a better clarity of it. And I hope you have also understood about the complexities. You can implement the same question with the frequency array as well. Okay, give it a try. So thank you. Thanks for the video. If you liked it, drop down in the comments, and you can like the video as well. Thank you.